Did you ever notice how the biggest events in our universe rarely arrive with noise? Sometimes they begin with a soft flicker, a tiny number on a screen, a shift so small that most people would never see it, but someone does. And that moment changes everything. This story begins in silence, a kind of cosmic quiet that stretches across millions of miles. Because, for months, astronomers had been watching an object drifting into our solar system, slow, cold, and harmless. They named it 3I/Atlas, the third interstellar visitor ever recorded. Nothing strange, nothing dramatic, just another rock from deep space, passing by on its long, lonely journey. At least, that's what everyone believed. In observatories scattered around the world, from the deserts of Chile to the frozen plains near the Arctic Circle, researchers tracked the object's path, night after night, measurement after measurement. It was routine work, watching a dim spot crawl slowly across the ecliptic, the imaginary line all planets follow around the sun. To the human eye, it looked ordinary. A faint dot, barely brighter than a distant star. The kind of dot you might ignore if you didn't already know it was there. But machines don't ignore. Machines record everything, every photon, every fluctuation, every heartbeat of light. And one night, a machine caught something strange. A flicker. Just a tiny dip in brightness. Like a breath. Like something inside the object had shifted just for a second. Astronomers brushed it off at first. Space rocks flicker all the time, spinning, tumbling, throwing uneven sunlight back into space. No reason to worry. But then, it happened again. A flicker. Then another. Not strong. Not dramatic. Just wrong. A kind of wrong that sits quietly in the back of your mind. The kind that whispers this shouldn't be happening. Weeks passed. 3I/Atlas kept drifting closer to the sun, moving along the ecliptic like a slow shadow. Still quiet. Still predictable. But that tiny irregularity in the light curve, that little up and down heartbeat, refused to go away. And astronomers hate loose ends. So they dug deeper. They zoomed in. They checked every telescope that had a line of sight. And slowly, a pattern began to appear. Not a clean pattern. Not obvious. But something was there. A rhythm sitting underneath the noise, like a faint pulse hidden behind static. Imagine listening to an old radio, all crackle and static, and suddenly you think you hear a voice. You're not sure. You turn the dial a little. You listen again. And there it is. Just a hint of something that shouldn't be possible. That's what this felt like. A whisper coming from an object that should be silent. The strange flicker drew in more eyes. Research teams from Europe, Asia, North America. Everyone wanted a piece of the puzzle. And every team saw the same thing. A light curve that didn't behave like rock, ice, or anything natural. Some nights, the brightness dipped just a little. Other nights, it jumped. Sometimes both, in a pattern too subtle to explain with rotation or dust. It was like the object wasn't just reflecting sunlight, it was controlling it. But no one dared say that out loud. Not yet. As winter turned to spring, excitement turned into quiet tension. No official alert. No big announcement. Just scientists staring at graphs, staring at data, staring at this tiny flicker that refused to follow the rules. Because here's the thing about anomalies in astronomy. They rarely stay small. Sometimes they grow. Sometimes they reveal things we're not ready to see. And with each passing week, the irregularity grew sharper, more defined, and more impossible to ignore. One night, a young astronomer in Hawaii, exhausted, half asleep, holding a mug of coffee that had gone cold hours ago, noticed something odd. The flicker wasn't random anymore. It lined up. Not perfectly. Not enough to make a headline. But enough to make her chest tighten. She ran the numbers again. And again. And again. Each time the pulse returned. Soft. Faint. But steady. Like a heartbeat from across the void. She sent her findings to a colleague on the other side of the world. He checked the same timestamps on his own data. And there it was. The same pulse. The same flicker. 2 telescopes. 2 continents. 1 object. Something was happening. The whispers began. In quiet hallways. In late-night Zoom calls. Behind locked office doors. What if this isn't just a comet? What if it's doing something? What if it's aware? No one wanted to sound foolish. No one wanted to risk their career over a few strange data points. But deep down, everyone felt the same thing. A growing, uneasy curiosity. Because 3I/Atlas wasn't acting like an object drifting on a random path. It was acting like something responding. Something adjusting. Something alive, or something designed. But science doesn't leap to conclusions. Science waits. Science watches. So the world watched. And the object continued its slow march through the darkness. By late summer, the flicker transformed from a minor curiosity into a global mystery. Every major observatory now tracked it. Every dataset seemed to highlight the same undeniable truth. The object was behaving differently. Too differently. Yet through all the confusion, one thing never changed. The quiet. 3i/Atlas made no sound. No radio signals. No thermal spikes. No dramatic flare-ups. Just a soft, persistent, impossible flicker of light. A signal that felt like it came from deep inside the object. Like something was shifting behind a veil. None of the models fit. None of the explanations worked. Everything felt off. And still, the object kept drifting closer. That's the part that made scientists uneasy. Because objects that break rules early tend to break bigger ones later. As autumn began, one final observation pushed the mystery over the edge. A set of back-to-back flickers, spaced almost perfectly apart. Not noise, not rotation, not sunlight scattering off dust. A pattern. A clear one. And in that moment, the scientific world held its breath. Because that tiny flicker, that little drop in brightness that began months ago, was now something else entirely. A message? A malfunction? A warning? No one knew. But one thing was certain. 3i/Atlas was not behaving like anything we have ever seen. And whatever was coming next would change everything. That there's a moment in every scientific mystery when the data stops looking like noise and starts looking like intention. And for 3i/Atlas, that moment arrived quietly. Not with an explosion, not with a flare of cosmic light, but with a rhythm. A slow, pulse-like beat, hidden in the brightness curve of a distant speck of light. It started with a question no one wanted to ask out loud. Why does the flicker look organized? At first, the dips were small, tiny drops in brightness that almost blended into the background. But as the object moved closer to the sun, those dips changed shape, sharper, cleaner, more defined, like someone was turning a dial and bringing the signal into focus. A team in Chile noticed the shift first. They watched the brightness drop, then rise, then drop again, with a precision that made the room go silent. No chaotic wobble, no random scatter, just clean, repeating shadows, appearing at almost perfect intervals. One of the astronomers whispered, "Objects don't do this." Another replied, "Not unless they're trying to." But no one hit publish on that thought. Not yet. Across the world, in Japan, another observatory caught the exact same pattern. The timestamp matched down to the second. A dip. Pause. Another dip. Almost like a heartbeat. Scientists stared at their screens, waiting for the next flicker, the next clue, the next answer. And it came. Exactly when the pattern said it would. The room erupted into chaos. Chairs scraping. Keyboards rattling. People talking over each other. Because this wasn't rotation. This wasn't dust. This wasn't sunlight bouncing off some irregular surface. This was timing. Deliberate timing. Something about 3i/Atlas was casting shadows with near-perfect precision. After that night, everything changed. Data centers around the world began coordinating around the clock. Researchers who had never spoken before were suddenly emailing at 3 a.m., comparing graphs, sending screenshots, trying to understand the same impossible thing. Why does an interstellar object have a pulse? Theories spread fast. Some said it was a natural resonance, a spin pattern we didn't understand. Others thought it was shedding layers of ice in an unusually rhythmic way. But most people knew deep down that the truth didn't fit those explanations. The shadows were too sharp, too clean, too perfectly spaced. Nature loves chaos. This wasn't chaos. One night, a veteran researcher in Germany ran the light curve through a filtering program he'd been using for decades. He leaned back in his chair, eyes widening as the clean signal appeared. The dips weren't just repeating, they were repeating in a ratio. A simple, elegant ratio that kept pointing to the same answer. This pattern wasn't formed by chance. He called his students into the room. They gathered around the monitor as he replayed the filtered curve in real time. Dip, plus, longer pause, then another dip. Someone whispered, "That looks like a sequence." Another whispered back, "It looks like something counting." Word began spreading through private channels, Slack groups, encrypted emails, late-night phone calls between colleagues who weren't supposed to share anything. Nobody wanted to start a panic. Nobody wanted to say signal. Not after all the false alarms. Humanity had survived in the last century. And still, every new observation pointed in the same direction. The shadows had structure. They were clean, predictable, mathematically crisp. One scientist described it best. It's like watching a lighthouse in the middle of deep space. As the days passed, more telescopes joined the search. They pointed their mirrors toward the object, capturing every flicker they could, before 3I/Atlas moved too close to the sun and became hard to track. And with each new reading, the pattern grew stronger, the dips sharper, the intervals more defined. It wasn't like any comet. It wasn't like any asteroid. It didn't match any known debris behavior. It was something else. Something casting shadows. Like it wanted to be noticed. Then came the turning point. A small observatory in Canada recorded a sequence so clean that even the most skeptical scientist felt the hair rise on his arms. The dips formed a perfect rhythm. For short shadows. One longer one. A pause. Then two more. It repeated again. 43 minutes later. And then again. 43 minutes after that. An intern asked the question everyone else was afraid to ask. Is that a message? The room fell silent. Nobody laughed. Nobody dismissed him. Because the truth was simple. Nobody could explain it. Not with physics. Not with probability. Not with anything we currently understood. The world outside had no idea what was happening. No breaking news. No headlines. No public alerts. Just a quiet storm building inside the scientific community. A sense that something enormous was sitting behind those shadows. Something patient. Something deliberate. And yet, no one could say for certain if the pattern was natural, or artificial, or something in between. Because the universe is full of surprises. Some harmless, some dangerous, some simply beyond our imagination. And as 3I/Atlas moved deeper into the inner solar system, its shadows grew sharper. Its rhythm grew clearer, and the pulses looked more and more like signals. From something that wanted to be seen, or something that wanted to be understood. In the final weeks before it approached perihelion, one last observation shook the scientific world. 3 pulses, a long shadow, then a pause, almost like a breath. Not random, not accidental, intentional. And suddenly, the question that had been whispered in labs and observatories around the world became impossible to avoid. Were we watching a natural shadow, or an intentional signal? No one had the answer. Not yet. But everyone felt the same chill. A sense that 3I/Atlas was about to reveal something bigger. And whatever that was, it was coming fast. Sometimes the universe surprises us with light. Other times, it surprises us with heat. Or in this case, the lack of it. Because just when scientists thought they were beginning to understand the strange pulses from 3I/Atlas, the object changed the rules. It didn't flicker. It didn't flare. It didn't spin or break apart. Instead, it cooled. Not slowly, not naturally, but sharply, like someone flipped a switch. And that moment would become the first real anomaly. The clue that forced scientists to ask a question they'd never expected to face. What kind of object can change its temperature, on purpose? It happened on a quiet night at a thermal observatory in Hawaii. A sensor that had tracked 3I/Atlas for weeks suddenly recorded a massive drop in infrared output. The object's temperature fell by more than 40 degrees in under 2 hours. A drop so extreme that the researcher on duty thought the machine had failed. He checked the cables. He restarted the system. He even hit the screen once, lightly, with the side of his hand. But the numbers stayed the same. Cold. And falling. Comets don't do this, he muttered. They just don't. Hours later, a station in Chile confirmed the same thing. Then one in Spain. Then one in Antarctica. 3I/Atlas was cooling. Even as it moved closer to the sun. If that sounds impossible, it's because it is. Space objects heat up when they approach a star. It's basic physics. Sunlight hits ice. Ice warms. The surface melts. Gas escapes. The object brightens. That's how it's supposed to work. But 3I/Atlas wasn't following the script. Instead of absorbing heat, it was rejecting it, like it was shielding itself, or regulating something inside. Scientists gathered in labs and offices, whispering to each other like people standing in a church. Nobody wanted to break the silence. Nobody wanted to be the first to say the words forming in their minds. Not yet. For days the object stayed cold. Stable, unmoving, like it had decided exactly how warm it wanted to be. And refused to change. But then, something even stranger happened. It heated up. Not from sunlight. Not from a flare. Not from any natural event. It heated from within. The thermal curve showed a clean, sharp rise. A spike so controlled it looked artificial. The object warmed itself to almost the exact same temperature it had rejected earlier. And the rise wasn't random. One level, then the next, then another. A scientist in Germany stared at the thermal graph and whispered, "It looks like calibration." Her colleague turned toward her. Calibration of what? She didn't answer. No one could. By now, 3I/Atlas had become the most watched object in the sky. Every major observatory tracked its thermal behavior, its light curve, its reflectivity, anything that might explain what they were seeing. And the more data they collected, the stranger the object became. Some hours it cooled so sharply, you'd think it was pulling heat out of itself. Other hours it warmed in smooth, perfect curves that matched no known natural process. It wasn't reacting blindly to sunlight. It wasn't following the laws comets obey. It wasn't losing ice, gaining ice, spinning, tumbling, or breaking apart. It was behaving with intention, almost like it was alive, or like something inside it was alive. But no one dared say that publicly. Not yet. The theories exploded behind closed doors. One group believed the object had a metallic core that could store heat like a battery. Another thought it was hollow, a shell of some unknown material that expanded and contracted with temperature. A more radical group suggested the object was wrapped in some kind of layered surface that could open and close like scales, controlling how much sunlight it absorbed. But the most whispered theory, the one people shared only at 2 a.m., after the graphs on their screens refused to make sense, was something far more unsettling. What if it's adjusting its temperature to protect something inside? Silence always followed that question. A long, heavy silence. Because if that were true, then the object wasn't a rock. It wasn't a comet. It wasn't debris from some broken system. It was something built, something engineered, something with a purpose. The breaking point came when the object crossed a region of space where sunlight was strong enough to heat any known surface by at least 20%. 3I/Atlas didn't heat up, not even by 1 degree. Instead, it cooled again, even lower than before. It was like watching a block of ice refused to melt in the middle of a bonfire. A researcher in Canada stared at the thermal curve and finally said what everyone else was thinking. "This isn't natural." Another scientist responded softly. "So what is it?" No one replied, because every answer felt wrong. Too big, too dangerous, too unfamiliar. Teams around the globe tried every model they had. They simulated comets, asteroids, dark icy rocks, hydrogen chunks, fragments from alien solar systems. Nothing matched. Nothing even came close. The object wasn't behaving like matter. It was behaving like a mechanism, a machine, something that chose its own temperature, the way a living organism regulates its own body. But if that were true, then who built it, who sent it, and what did it want? These were the questions scientists asked privately, quietly, as if speaking them too loudly might make the answers come true. Late one night, after weeks of confusion, a small research station in Norway detected a new thermal shift, a rise so controlled, it looked like a single, clean breath. The temperature lifted, held steady, and then flattened into a perfect line. No curve, no wobbling, just a straight, flawless plateau, a signature. That was the moment scientists realized. They were no longer observing a natural visitor. They were observing behavior. Something was regulating itself. As it drifted deeper into the solar system, in total silence, no radio signals, no heat flares, just quiet, calculated temperature changes that matched nothing we understand. And for the first time, a chilling question began spreading across the scientific world. If this object can change itself on purpose, what else can it do? The answer was coming, and it was closer than anyone realized. There are moments in science when the universe feels less like a place and more like a presence that watches, a presence that waits, a presence that speaks, not with words, but with patterns. And for 3I/Atlas, that voice arrived as a rhythm, a pulse, a repeating beat, echoing across telescopes on opposite sides of the world. At first it looked like coincidence, a random dip in brightness that happened to show up at the same time in 2 different observatories. But then it happened again, and again, and again, until coincidence stopped being an option. It began early one morning, At a radio-optical lab in New Mexico, the team had been tracking 3I/Atlas for weeks, carefully recording every flicker and shadow that crossed its strange light curve. But at 4:12 a.m., a new kind of signal appeared. A pulse. Sure. Clean. Precise. One researcher leaned closer to the screen, as the brightness dipped for a fraction of a second, and then climbed back up. What was that? Someone asked. No one answered, because a second pulse arrived. Exactly 14 minutes later. Not 13. Not 15. 14. Down to the millisecond. Meanwhile, halfway across the world in South Africa, another observatory recorded the exact same dip. At the exact same moment. The timestamps matched so perfectly that even the most skeptical scientists felt a cold chill run through them. Signals in astronomy are messy. They wobble. They scatter. They carry the chaos of space. But this one didn't. This one hit like a metronome. One researcher whispered, "It's a rhythm." Another replied, "A rhythm from what?" Over the next 24 hours, the pattern spread through the global network, like a heartbeat moving through veins. Japan, Argentina, Alaska, Portugal. Every telescope saw the same thing. The same dip. The same rise. The same interval. 14 minutes. 14 minutes. 14 minutes. A flawless cosmic drumbeat, rippling across the ecliptic. This wasn't just brightness variation. This wasn't dust. This wasn't rotation. This was timing. Timing so strict, it felt intentional. Inside labs and universities, scientists huddled around monitors, with the kind of attention usually reserved for breaking news. Graphs were printed. Signals were compared. Data was layered and aligned. And when they stacked the readings from every observatory on Earth, the truth became impossible to ignore. All of the pulses lined up perfectly. Not one observatory was out of sync. Not one signal arrived early or late. It was identical everywhere. Like something inside 3I/Atlas was speaking, in a single voice, to the entire planet. Soon, researchers began noticing something even stranger. Every time the pulse hit, the brightness dipped, in a way that looked almost mechanical. Clean drop, and a clean return, that matched no known natural process. One astrophysicist described it like this. It's as if something inside the object briefly shuts off the light, and then turns it back on. Another replied softly, or blocks it, on purpose. Nobody laughed. Nobody dismissed the idea, because the deeper they looked, the more deliberate the pattern became. No spin, no ice ejection, no random scattering of sunlight, just a repeated shadow, passing through the light, every 14 minutes, like the ticking of a cosmic clock. Before long, the pulses started changing, not wildly, not chaotically, but gradually, like a message adjusting itself, to be more clearly heard. The dips grew sharper, the interval shortened, from 14 minutes to 12, then 11, then, for one brief stretch, exactly 10 minutes. The shift wasn't random. It followed a smooth curve, as if the object were slowly syncing itself to some internal rhythm, a rhythm that felt disturbingly alive. One night, a young data analyst at MIT overlaid the pulse pattern with the temperature readings from the previous weeks. Her hands froze over the keyboard because the rhythms matched. Every time the temperature shifted, a pulse followed. Every time the object cooled, a pulse echoed through the light. Every time it heated, the pulse sped up. It was all connected. Heat, light, pulse, rhythm, like a system, a network, a mechanism, something regulating itself. As it traveled deeper into the solar system, in total silence, "What kind of object does this?" she whispered. Her supervisor answered quietly, "Not a natural one." By now, 3I/Atlas was no longer a scientific curiosity. It had become a mystery, so deep and so precise, that even seasoned researchers felt a sense of awe and fear. Because if the pulses were natural, then nature was behaving in a way we had never seen before. And if they were artificial, then something out there, something unfamiliar, was controlling its own brightness, in a way designed to be detected, a cosmic heartbeat, sent into the dark, for anyone watching the sky, for us. As the object drifted across the ecliptic, the pulses grew stronger, as if the proximity to the sun gave the rhythm more power. Some scientists thought it was reacting to solar radiation. Others believed it was accelerating, some internal process. But the most unnerving theory came from a quiet researcher in Japan. He said, "Maybe it's not reacting to the sun. Maybe it's reacting to us." The room fell silent, because everyone had wondered the same thing. If something inside 3i/Atlas was trying to be seen, then why now? Why this moment in history? Why this approach through our system? And most importantly, what happens when the rhythm ends? The answer was coming. And with every synchronized pulse, the world grew one step closer to learning the truth that there's a moment in every investigation when the data stops whispering and starts lying to your face. And for the astronomers watching 3i/Atlas, that moment arrived the day its surface began to shine in ways no natural object ever should. Is where the story changes. For weeks, researchers had been tracking the object with calm confidence. Its path was clear. Its speed was steady. Its behavior was quiet, predictable, almost gentle. But then, someone noticed something strange in the reflectivity logs. A tiny spike, barely a blip. Most teams ignored it. A glitch maybe. A sensor hiccup. Nothing more. But the spike came back the next night. And the next. And the next. Each time sharper. Each time brighter. Each time timed so cleanly that even the most skeptical minds felt their confidence crack. Just a little. Late one night, at a university observatory buried in the mountains, a graduate student stared at her monitor with her hands shaking slightly above the keyboard. She watched the reflectivity graph rise, plateau, then jump, fast, vertical like a wall of light. She whispered to her supervisor, "Sir, that's not scattering. That's movement." Her voice was so small, it barely filled the room. But the data filled the world. Emails shot across continents. Encrypted channels buzzed. Space agencies that rarely spoke suddenly demanded new measurements in new wavelengths, infrared, ultraviolet, radio. And every new test came back with the same uncomfortable truth. The surface of 3i/Atlas was changing. Not slowly, not randomly, not like a comet shedding dust or ice, but sharply, instantly, like something was rearranging itself. Imagine watching a mirror shift its angle in the dark, catching light from a new direction. That's what these astronomers were seeing. Except here there was no mirror, and no reason. The spikes weren't weather. They weren't debris. They weren't physics as we knew them. Something was reflecting the sun in a controlled way. Almost like panels. Or plates. Or surfaces that could rotate, bend, or fold. And that's when the first person said it out loud. What if 3i/Atlas wasn't natural? Across the scientific community, the idea spread like a quiet flame. Some tried to put it out. "It's a tumbling rock," they said. A shattered object with uneven surfaces. A cluster of reflective minerals. But the models disagreed. Over and over again. The reflectivity pattern wasn't chaotic. It wasn't noisy. It wasn't messy. It was precise. Repeating. Intentional. Even worse, or maybe better, the spikes were aligned with the pulses seen in the light curve from earlier chapters. Almost like the object wasn't just reflecting light. It was using light. Choosing how to appear. Choosing how to hide. Choosing when to shine. And that terrified people in ways they couldn't admit out loud. Weeks passed. Hundreds of hours of data stacked up. And then came the moment that pushed the entire investigation into a new realm. A European observatory captured a long-duration exposure, and instead of a steady glow, the object flashed in 3 distinct phases. Bright, dim, bright again. Perfect spacing. Perfect timing. Not random. Not geological. Not natural. One scientist leaned back in his chair and murmured, "It's changing shape." Another replied, "No, it's showing us something." Because that's what it felt like. Like a reveal. A slow, deliberate reveal. As if the object was testing angles. But then, without warning, everything stopped. No pulses. No reflectivity spikes. No temperature jumps. No geometric flares. Nothing. A silence so complete. It didn't feel like absence. It felt like a decision. It happened at 3:12 Universal Time Coordinated, a time when half the planet slept, and the other half watched the data feeds like nervous parents. One moment the thermal readings danced with life, and the next they dropped off a cliff. A clean, perfect flat line. Sensor error, someone muttered. But then a second observatory reported the same thing, and then a third. By the time the fourth confirmed the silence, fear settled over the scientific community, like dust over a forgotten room. Because space never gives perfect zeros. There's always noise. Always fluctuation. Always something. Nothing in the universe is that quiet. Unless it chooses to be. Radio telescopes swept across the object's coordinates, listening for even the smallest whisper. A crackle. A hum. A trace of static. Anything. But the receivers picked up nothing. Except the natural hiss of the cosmos. One researcher stared at his monitor, eyes wide, voice cracking. It's like it turned itself off. Another answered, barely above a whisper. Or it turned away from us. That idea lingered in the room. Like a cold draft no one wanted to acknowledge. As hours turned into a full day, news began leaking out. First through private forums, then through astronomy blogs, then through social media channels that had been tracking 3I/Atlas from its first anomaly. People expected excitement, more revelations, more impossible moments. Instead, they got a silence that felt intentional, calculated, designed. Why would it stop? Why hide now? What did we do wrong? What did we miss? Questions drowned the world, but answers stayed locked behind the object's new darkness. Inside a small observatory in Chile, a young scientist replayed the last pulse again and again, as if the truth hid in the final milliseconds. She said quietly to her colleague, "What if that was the last thing it wanted us to see?" Her colleague replied, "No, it's not done. Nothing behaves this perfectly by accident." He didn't say the second half of his thought. Not unless it's alive, or built, or following some kind of plan. The thermal silence grew more disturbing by the hour. A natural object, a rock, a comet, an icy fragment, should warm under sunlight, should release heat, should show variation. But 3I/Atlas showed nothing. Its surface dropped to a uniform temperature that defied both distance from the sun and basic physics. Thermal suppression, someone suggested in a closed-door meeting, like it's shielding itself. Another replied, "Why would it shield itself after sending signals?" The room fell silent. The idea was too big, too heavy, too final. What if the earlier pulses weren't mistakes? Weren't random events? Weren't natural faults? What if they were a test, a scan, a probe? And now that the object had what it needed, it no longer required us. Theories multiplied. Some believed the silence was defensive, a way to avoid detection, a cloak. Others believed it was strategic, a waiting period, a reset. A few whispered something darker. What if it's listening now? Because every time humanity observed 3I/Atlas, we send our own signals back. Radio waves, radar beams, lasers, tiny technological fingerprints, carried across space. What if, after seeing our curiosity, it decided to study us in return? A quiet object can still watch, still measure, still learn. Silence doesn't mean absence. Sometimes it means attention. Meanwhile, the public conversation spiraled. Conspiracy videos, live streams with blurry graphs, claims of cover-ups, claims of extraterrestrial contact, claims that the silence meant danger. Governments tried to downplay the situation. Nothing unusual. A normal cometary behavior. Expected cooling. But no one believed them. Not after the geometric flare. Not after the light pulses. Not after the impossible rotation at perihelion. Humanity had stared at something that felt alive. And now that it had gone quiet, the quiet felt louder than any signal. By the third day, a strange mood settled over the research teams. Not fear. Not wonder. Something deeper. Something harder to describe. Felt like standing in a dark room. After someone has turned out the lights. Knowing they're still there. Knowing they're still watching. But unable to see their shape anymore. One veteran astronomer finally broke the tension. "This silence isn't empty," he said. "It's intentional. Objects don't erase themselves from the universe. Only devices do." The word device hung in the air, like an echo no one could swallow. And then, just before the chapter closes, a final piece of data arrived. Small, faint, almost nothing. But not quite. A single drop in luminosity. Barely measurable. Almost invisible. But too sharp. To be natural. Too clean. To be random. As if the object blinked. Once. Just once. A reminder. A signal. A breath. Proof that the silence wasn't the end. It was only the beginning of whatever message 3I/Atlas truly carried. And now the question hangs over the world like a shadow. If silence itself can speak, what is it trying to tell us next? There's a moment in every great mystery when people finally say the quiet part out loud. And with 3I/Atlas, That moment came long after the silence began, long after the pulses stopped, long after the flare at perihelion carved its perfect wedge of light across space. It began with a single idea, a bold theory spoken in a small room, by a scientist who had run out of natural explanations. What if it's a probe? The room froze. Because once that word enters the conversation, you can't pull it back out. The machine hypothesis didn't come from conspiracy forums or wild guesses. It came from the data itself, from the silence too perfect to be random, from the thermal patterns that turned on and off with intention, from the controlled tilts at perihelion, from the geometric reflectivity spikes, from the object's ability to hide and reveal itself, like something that understands both light and watchers. Piece by piece, all the strange behavior lined up behind a single possibility. 3I/Atlas wasn't behaving like a rock. It was behaving like an instrument, a device, a machine. In a private meeting among senior astronomers, one researcher stood up and drew 3 simple shapes on a whiteboard: a sphere, a line, a curve. This, he said, pointing at the sphere, is a comet. He moved to the line. This is what 3I/Atlas should be doing. Then he circled the curve. And this is what it's actually doing. The difference was uncanny. Natural objects drift. They tumble. They scatter sunlight in sloppy ways. But 3I/Atlas? It behaved like something adjusting itself. Light, heat, rotation, reflectivity, with the precision of a device responding to changing conditions. A machine that had traveled for who knows how long, from who knows where, for a purpose we still couldn't name. The theory spread quietly at first. A few hushed messages, a few encrypted files, a few late-night emails with subject lines like pattern recognition hypothesis, thermal control model, non-natural rotation curves. But the more scientists ran simulations, the more they realized how little of the object's behavior could be explained by physics alone. Thermal changes that defied the sun's influence, reflectivity spikes that appeared engineered, silence that was too clean, too absolute, perihelion rotations that looked designed. All of these hinted at the same unsettling truth. 3I/Atlas was not just traveling through our solar system. It was studying it. One theorist described it this way: if you wanted to understand a star, you wouldn't fly straight into it. You'd approach. You'd test angles. You'd measure heat. You'd watch how the light changes. You'd collect data. Another added something even more chilling. And if you were studying life, you'd stay silent. You'd observe first. You'd reveal yourself only when necessary. Silence wasn't the absence of communication. It was a strategy, a way to listen, a way to record, a way to understand without interfering. And suddenly, the earlier pulses didn't look like signals meant for us. They looked like calibration checks, self-tests, system alignments, data snapshots, not messages, modules, functions, protocols. The hypothesis grew stronger when analysts revisited the thermal readings. The object didn't heat normally, didn't cool normally, didn't obey the sun the way everything else does. Instead, it regulated itself, keeping its temperature within a range, too smooth to be geological, and too responsive to be dead. Like a probe adjusting its internal systems, to protect sensitive components, or to maintain performance, or simply to survive. One scientist wrote, "This is not the behavior of a natural body. This is the behavior of an observing mechanism." And that sentence became the heart of the discussion. Not a rock, not an asteroid, not a fragment of ice, but a mechanism, a machine, a visitor built for endurance, for data collection, for long-distance travel, which raised the question no one wanted to face. If it's a machine, who built it? Another question followed, darker, heavier, harder to swallow. If it's studying our star, is it also studying us? Because every time we looked at it, we sent signals. We sent noise. We sent technology. We sent intention. We revealed our level of advancement with every observation we made. And now that the object had fallen silent, now that it had shut down its thermal signature and flattened its light curve, some researchers believed the meaning was simple. It had gathered enough. Others said something even more unsettling. It's waiting. Waiting for what? For a response? For alignment? For a phase of its mission we couldn't detect? For us, a senior astrophysicist proposed an idea so unnerving that the room went silent after he spoke. What if this isn't the first time it's been here? If 3I/Atlas was truly a probe, could be ancient, older than human civilization, older than recorded history, something that has passed by before, seen Earth rise and fall, and return now because the conditions had changed, because we had changed, because there was finally something here worth observing. Not animals, not early humans, but a species that built telescopes, that measured the stars, that sent probes of its own, life that had crossed the threshold, from survival to curiosity. If 3i/Atlas is a machine, it might have been waiting for exactly that, and now it had found us. But the most haunting part of the machine hypothesis isn't what the object might be, or how it behaves. It's why now? Why in this era? Why this generation? Why this moment in human history? Is it coincidence? Cycles? Timing? A predictable orbit we just never noticed? Or is the timing intentional? Chosen? Meaningful? One scientist said it with a trembling voice. If it came here to observe us, it means we passed some kind of test, or crossed some kind of threshold, or became relevant in a way we weren't before. The room fell quiet, because that idea, the idea that something out there has been waiting for us to awaken, it's a place deeper than fear. It hits the part of us that wonders if we are alone, or if we are being watched by something vastly older than ourselves. Something patient, something precise, something that learns by silence.